can everyone hear me at the back? Yeah? Okay, so I'm just going to skip that one. Hello everyone, my name is Imar. I'm the VP of Big Data at Kobo. So Kobo is one of the Rakuten companies. And I definitely appreciate you all coming here today. There are a lot of exciting sessions happening in parallel, so thank you for taking the time to attend this one. What I want to talk about today is big data for eBooks and eReaders. And so I'm going to try and focus mostly on things that are unique and interesting in the context of our particular business, which is eBooks. So let me just give you a little bit of an introduction about Kobo. So Kobo was founded in 2009, the end of 2009, so December 2009, sorry. So it's almost 5 years old, and in November 2011 it was purchased by, it was acquired by Rakuten. The headquarters are in Toronto. It's about 400 or so people. A little less than half of them are in the R&D department. And what do? We sell ebooks, e-magazines, and we also make devices. So we make e-ink readers and tablets. The most recent device that we've launched is the Kobo Aura H2O. So this is a water-resistant device. You can actually go and sit in the bathtub or take a shower with it. This is something that I personally, as an avid reader, wanted since I was 5 years old. So I'm very excited about this product. I have one, I use it, and my unbiased opinion is that it's excellent. One of the principles at Kobo since its foundation is the idea that we want people to be able to read on any device, and we want them to be able to actually use whatever books they already have. So we support the EPUB format, a non-proprietary format. You can read things that you've bought at Kobo, but you can also read things that you've gotten from other sources, hopefully the public library or somewhere else that's legal. We have the e-ink reader, and then iOS, Android, Windows 8 platforms, as well as a desktop reader. Where is Kobo present? So Kobo has official presence in all of these countries above, which means that we have formal partnerships with both local retailers to sell the devices and also companies, typically indie booksellers and other local partners that promote Kobo, and also integration of various types with existing websites in these countries or Kobo websites for these countries. Kobo also has a self-publishing platform, so anyone can upload a book that they've authored, decide how much they want to charge for that. Kobo will take a cut and become a published author, which means that we actually have books in languages that go beyond just these 13 or so languages. We have in our catalog, which is quite large, it's about 5 million books. We have books in over 140 different languages, and we have around 20 million users. We have a few hundred thousands of these self-published ebooks. So there's a lot of data that comes into the big data group. So first, what you would expect, so all of the interactions that users have on their website when they're clicking through, looking at books, deciding to purchase, moving through the purchase path, as well as on the devices when they're doing these activities. And the other type of activities that we see is what users are reading, flipping, etc. So the interaction with the reading material. So that translates to quite a lot for us. So it's about 100 gigs of data that come through our system every day for processing. In the big data team, we use a whole lot of different technologies to crunch through the data and get the numbers that we need. So for processing and streaming, we use a lot of Hadoop, of course, Storm and Plume. We use any type of storage that matches the needs for the particular product. So we use a variety of SQL solutions as well as key value storage. Our search platform is based on Solr with plugins that we write to improve the search. And we write in a whole variety of languages and statistical analysis tools. The big data team is about 10 people. It's a mixture of data scientists, research scientists, and engineers. So what is it that we actually do? So I'll briefly go through some of the things we do, which I think every company that has a website or an app probably does. So these are what I would say, the less sort of the more common things that I can tell you about, and then I'll go into more detail about the interesting things that have to do with the fact that we sell content, digital content. So we support the search platforms. We do improvements on top of Solar, doing things like query suggestions. So you query for this, maybe you meant something else. We do the re-ranking of the results as they come out of Solar using all sorts of signals that we know about the user. We support some modes of personalization, so we know what you've already bought, we know what we've recommended for you, and we use that to adjust the way that we present results to you. Because we deploy a lot of different algorithms, we always have to A/B test them. We always have to know that it's improving our revenue or whatever KPI we're looking at. And so we've built some sort of knowledge around A/B testing, and we typically do both our own A/B testing and provide A/B testing support and analysis to different groups in the organization that need that and don't necessarily have the know-how. So when the device teams want to run some A/B tests, we would typically analyze the results for them, collect the data and analyze it. We do predictive analytics, so we need to know as a new customer comes in, starts purchasing, what is their lifetime value, are they likely to stop using the product, so that we can take this knowledge, give it to the business, and then they can build campaigns around it. For example, try and engage you in purchasing more, give you coupons and so on. And we do recommendations. So recommendations typically come in two flavors. The first one is what we recommend personally for you. We know what your library is. We know some other things about you, and we choose books that we think will be particularly good for you. And then the other variant is related titles. So this is the users who bought this also bought that. So it's not specific to you. It's about a product, about a particular item. So I think pretty much everyone who's in e-commerce or digital content and has a website and sells stuff will have these kind of things going on in their organization. So now I want to take some time to talk about what I think is sort of more unique and interesting in our situation. And so I think the basic premise is there are two things that we can do with our product. The first one is we can see how the users consume the product. So we can actually see when they started reading and how they're reading it and when they're done reading it and so on. And the other thing we can do, which I'm now blanking out of, so I'll get to that in a moment. Okay, so I'll just move to that and I'll get back to that, sorry. So, so of course, we have access to the actual content of what we're selling, so we know what it is. It's a bunch of words, we can analyze them, we can process them, and we can make some smart things with that. So the first thing we noticed is that related titles, so users who bought this also bought that, was really helpful. So once we've deployed it, we saw a great increase in our revenue. We know that a large chunk of our sales come from that, and so we just want to do more and more of it. But I think like a lot of companies that have a large catalog, there is a very, very long tail for books, in our case, or products that are not really bought by a lot of people, and so you can't look at the collaborative filtering approach. You can't look at co-purchases in order to recommend other products. What other companies typically do in that scenario, I imagine, is they look at the metadata and try, or manual tagging of the content, and try to increase that, try to develop recommendations based on that. But we can actually look at the actual content of the book, the actual text of the book, and analyze it. So what we did there, which was for about like a very large chunk of our catalog, fell into that long tail where we didn't really have enough co-purchase information in order to provide good recommendations for. We used a fairly mature by now technology, a probabilistic graphical model for topic modeling, which is called Dirichlet allocation. The general idea, for those of you who are not familiar with it, is that basically we view every document, every book in our catalog as a distribution over topics. And what is a topic? A topic is just a distribution over words. And so here I'm showing you a few topics that were inferred by the system for the books in particular. And you can see that the green one probably is a topic that has to do with books that are mostly about nutrition and health and so on. The orange topic is probably something that has to do with cooking, recipe books, and so on. And then this is probably a topic that has to do with business books, software in particular. So this is an unsupervised approach. We basically jointly learn these topics, which again, these are the words in the topic that have the highest probability of occurring under the topic. And we also learn for every document the distribution over topics for that particular document. So that means that every document is now represented in a very compact form, basically as a feature vector. This feature vector can be used to simply measure similarities between different documents that are based on the content of the book. And so we can use that in order to leverage the content to find related titles and then serve related titles to these books that we don't have co-purchase information for. And that proved to be quite useful. So about 10% of the related title purchases we have right now come from books that would otherwise not have any related titles. Another thing what we need to do is we need to detect similarities between different books. So pretty much every catalog, every e-commerce catalog has the duplication problem. You need to realize that 2 or more of your products are actually the same product. And in our case, it's even more interesting, I would say, because the existence of multiple variants of the same book sometimes implies actual plagiarism. So the first order of business for us is to not allow people to upload through this self-publishing platform a book that they didn't write, right? Unless, of course, it's a public domain book. And so we build a system to detect similarities between books that flags any book that looks like a plagiarized book. And every book that is published by the self-publishing platform needs to go through this automatic verification, and then if it's flagged, someone needs to look at it. Some other reasons why we want to do this similarity detection between books are more typical. So we want to be able to correctly and accurately measure different metrics. So if we want to know which book has sold very well in a particular year, we need to know that all of these books are the same book. This is actually, this is a real example. So we have a lot of different variants of 12 Years a Slave. They all popped up pretty much after the book, the film based on the book won an Oscar. People realize that this is a public domain book, so they can basically take the book, upload it, charge $3 or $2 or $7, and people will buy it, even though you can actually find a free version if you're looking. And from our perspective, we just needed to know that this is the same book. Another motivation for doing this, finding this global assignment of all of these books to the same product is just in terms of running our algorithm. So again, if you know that these things are the same, you can collect all the metrics for them, and when you compute related titles and recommendations, you do a better job. And it's actually also a performance issue, so you're decreasing the size of your input to the algorithm by collapsing all of these similar items together. And for public domain books, we have sometimes hundreds of different variants of the same book. The way we do the similarity analysis is fairly straightforward. We look at the book, we look at it as a bag of words representation, we do some normalization, TF-IDF normalization, basically looking at the more important and unique terms for the book, and then we compute similarities. The challenges are mostly engineering ones, because you need to do this comparison for every book, so every book to every other book, and so we've built some neat tricks around that, but in terms of the actual computation, there is nothing too exciting about it. So that's one other tool that we have, which is based on the this one is a nice touchy topic. I didn't put any images. Probably figure out why. So people read porn. You might find it surprising. About 5% of our readers enjoy it, and it's fine. It's allowed. Actually, I think it's even more prominent with e-readers, because nobody knows you're reading, right? You could be sitting in the subway and reading your porn. Think about that the next time you sit next to someone who's reading on their e-reader and looks pretty heavy. And we want to allow that kind of thing. We're not against it in principle. But, of course, we do want to protect some of the users against it. We don't want to necessarily show these titles in our top 50 best-selling books, even if they are, just because some people will be offended. We don't want to autocomplete some more challenging titles for you again, because you might not actually want to see it. So the interesting thing that we did here, and again, The actual solution was a fairly run-of-the-mill classification algorithm with the extra added caveat that we didn't want to just classify adult or non-adult. We wanted to do a more fine-grained work because, again, we are okay with selling more sexualized material, but we need to know how sexualized it is. And so we divided it with the help of the merchandising team who gave us some direction into 4 different categories. So the first one is normal, something that everyone should be okay to read. Then the next level is what we call sexy. So this is where 50 Shades of Grey, for those of you who've read it, probably not a lot of people here, falls into. So maybe not for your children, but you wouldn't mind reading it. Then the next one is porn. That's actually books that have very little in terms of plot and character development. And then the last category is the banned category. So there are actually topics that Kobo doesn't want you to write about or publish through our platform. These are things that violate our content agreement. These are things that are taboo, illegal. And so we definitely need to be able to flag this and not allow people to upload them to the system because, again, there is, when you, as a self-published author, when you upload a book, you sign this contract, but really how are we going to know that you're following the contract unless we do this type of analysis? And this is, again, something that every new book that gets uploaded through the self-publishing platform go through this analysis, and if it gets flagged, someone needs to go and check it. So Beyond the Book is a project we did last year, which is a content-based project. So what we wanted to do is enrich the reading experience by finding interesting things in a book and relating them to interesting things from the internet, right? So it was a relatively vague ask from the UX team. So what we decided to do is, like, the internet here would be Wikipedia because it's a relatively reliable source of information. And the way we approach this problem is, first of all, we do the key term detection in the book. So we look at the book, we do some of the standard analysis, we come up with a bunch of terms that are prominent in the book and unique to the book. And then the hard part, as it turns out, is the disambiguation. Because when I tell you that there is a character Gandalf in the book, you all, or a lot of you know that I mean The Lord of the Rings or The Hobbit. But actually in Wikipedia there is 17 different disambiguations of the term Gandalf, right? So which one do I need to link the information to? So there is Gandalf the magician, the white, the gray, and there is Gandalf the band, right? And then finally, after we do disambiguation, we have an associated detection score for each one of the terms. We have a disambiguation score. How sure are we that we disambiguated it correctly? And then we want to basically filter out some terms that we don't think are going to be either correctly relevant or correctly disambiguated or just not particularly interesting. And so I'll just spend a few minutes talking about the disambiguation part of things. So the problem statement is we want to disambiguate items to Wikipedia article mapping. And the way we approached it, based on some work from the literature, is we look at the disambiguation per term that makes sense collectively. So rather than trying to disambiguate them one at a time. So let me explain this a little further. So let's say that we have 3 terms, Gandalf, Hobbit, and Bilbo Baggins. So you probably all know Hobbit from Lord of the Rings, but maybe you didn't know that Hobbit is also a measurement unit in Wales. It's half a bushel. It's also a computer system from the former USSR. Gandalf is the magician. It's also the band, as I've explained. And finally, it is a figure from the Nordic mythology that has nothing to do with the book, except being an influence, probably. And Bilbo Baggins is, again, the guy from the books, but also another fan. So if I look at any sort of randomly selected potential disambiguations as a cohort, and if I look at how related their Wikipedia terms are, then they're not going to be particularly related. I can look at relatedness of Wikipedia pages by either the actual text, or I can use the approach of just looking at link structure. So all of the incoming links, let's say, into a Wikipedia page, how much of an intersection is there between the incoming links into one term and the incoming link into another term? So basically, by looking at Wikipedia link structure, I can compute a similarity score between each one of these disambiguations. And what I'm looking for is a collection of disambiguations that have the highest similarity score together. If I wanted to formulate it so this would be the example where the incoming link structure measured in terms of the similarity metric will give me the highest score. So if I wanted to pose it as sort of a theoretical problem, this is, we're looking for a k-click, a max-weighted k-click in a k-bar graph problem. So actually it maps very nicely to sort of standard problems from graph theory. There are probably some standard approaches with very nice asymptotic bounds to them, but the problem is NP hard. And so we use the greedy approach. This is what you do when you need to solve problems in the real world. The thing is, we could make one strong assumption that motivated using a greedy approach, which is it's very unlikely that there are two or more completely disjoint sets of explanations that make sense together. So, if the terms are related, there's probably just one way in which they are related, the same terms. So based on that, we can actually start with the best similarity between terms and sort of propagate it further and build the entire click from there. And what does it look like? So as you're reading on the app, and if you choose to turn on the feature, there are some terms that will be highlighted. This is from Chris Hadfield's book, An Astronaut's Guide to Earth, to Living on Earth. And if you click on one of these terms, you go to a page where you see the different terms that appear in this particular chapter, or maybe in the entire book. You can choose to press on each one of them, where you'll get some more images and information. So we used Wikipedia, as I mentioned, but also we used Freebase, which is a structured representation of a lot of Wikipedia content and other content. And one interesting thing that we can do, going back to say the overlated titles, is we can give you now related titles that are based on a particular term rather than something else. So we can pull out all of the other books that had the term in them as a key term and show you these books and allow you to sort of explore other material on this topic if you want. So I've given some examples of how we can use the content to do some interesting things, and now I'm going to talk about something that is not particular to content. So this is something that anyone that has a web page with particular properties can use. I just think it's an interesting project that we're currently working on. So the website, if you look at it, is one way to describe it is just a bunch of lists. So every list is something that was either generated automatically, like the top 50 books or the recommended for you books, but also things that are created by our merchandising team. So the top new releases, some books from best-selling lists on the New Yorker and so on. And then the question is, what is the right way to order all of these lists so as to optimize the revenue from your page? And clearly, there is an exponential number of ways in which you can reorder these elements. And obviously, it's not feasible to run all of these versions, say, in an A/B test framework, because it will just take you forever. So how do you go about finding the best layout, or at least a good layout for your website? There are two issues here. One of them is, since you're not going to test all of the different layouts, how do you generate reasonable layouts in an automatic manner? Because you're actually, part of the requirements here is that you don't want people managing these different layouts manually and creating them manually. So how do you automatically come up with layouts for the web page that are reasonable enough to test? And the second one is, given that you've done this, how do you actually find the best one? So in terms of the layout generation, what we did is we treated this as a optimization using a local search. So what you can do is you do start from a small set of layouts that an expert generated. So maybe someone from the merchandising team gives you different variants that are all likely to be quite good. And then you can choose to do one of two things. You can either take two elements on the web page and swap them, or you can completely remove an element and insert a new one instead. So for example, you completely remove one list and insert a new one that previously wasn't on the web page. And of course, you can just also delete or insert a new one without removing something from the web page. So this is the way that we wanted to generate automatically layouts from existing layouts. So that was our approach for the first part of the problem. The second one is, how do you optimize? How do you find the optimal solution? Oh, and one thing I want to say about this is you can randomly choose the swaps or exchange moves, but you can also make it more informed by looking at what you know currently about the statistics of these different lists. So from the web page analytics, we know that a particular list is performing well or not performing too well, and we can use that to stochastically either to sort of randomly sample what to swap, but in a way that reflects the analytics we have currently on the list. So better lists, as we know, will propagate up to the page. Now, of course, you have to take it with a grain of salt, because some of the reasons some lists are not performing well is just because they're so further down the screen that nobody ever gets to them. Maybe they are good lists. So in terms of the optimization, we use what's called, within the exploration exploitation framework, there is something called the multi-arm bandits. It is a framework that maximizes the total expected reward, and there is a Bayesian framework that we used here. But the main idea here is that you start, say, with splitting your user. Let's say that we're testing 2 variants, so you do a 50-50 split of your users. But then instead of waiting until you reach statistical significance to then decide which variant you're going to use, you're reallocating the user distribution between the variants on the go. So you can either do it online, or you can do it in a batch mode, maybe every day. But you basically use what you know right now about which variant is performing better to recompute who goes where, which user sees what. And you do that in, again, a randomized way which respects what you know right now. So what you currently know, you have for each one of these pages the probability that they are the better variant. And so you sample from these 2 distributions, which means that most of the time you're going to assign your user to the better performing variant, but not all of the time. And this allows you this exploration strategy. What this also means is, as you're running this test, if there is a clear winning strategy, you're going to pick up on that and allocate more and more of your users to it, which means that you're not losing as much money as you would have otherwise lose. Because if you're running an A/B test, you have to wait until you reach statistical significance. And as you're waiting for that statistical significance, you're basically losing half of the gain in that period of time. And so if you're continuously improving and you're always running A/B tests, you're always losing this money. So this strategy is going to not, of course, recover all of the costs, but at least while you're running the test, it will, with high probability, give you better monetization value of the better variant. Another nice aspect of this strategy is that you can continuously do that. So you can test the multiple variants at the same time, and you can decide at some point that you don't like a particular variant, it's not performing well, and so you take it away from the list of variants you're trying, and then you swap in a new one. And then you continuously explore and remove variants and add new variants. There is also, what we realized pretty quickly is that there is not necessarily one best answer, right? So this whole notion of personalization needs to be considered here. So maybe there are variants of the web page that are particularly good for some types of users, and if we just try to find a single winner, we're never really going to address all the different needs of our users. So in order to be able to optimize for that, what you need to do is you need to introduce some knowledge about your user, and this is called the context-sensitive variant of the multi-armed bandit. So as a user comes in, and you consider which variant to show them, so you do this computation, rather than just sampling from these distributions, you actually generate a representation of the user as some feature vector that has to do with what we know about them. And each variant is associated with a set of parameters that are learned as part of these experiments. And so you compute for this particular user how well suited he is or she is for each one of these variants. And of course, the answer differs depending on the user's feature vector. And so what do we put in this feature vector? So we look at the types of books that they have in their library and the genres associated with these books. So the different account of books in every genre is some of the features we use. We also look at how sensitive they are to the price, so whether they're buying things that are cheaper or more expensive, is there any cost sensitivity? Are they buying things that are very new or moderately new or just classics, and so on. And finally, we also use it we look at some of their browsing behavior. So, so that's what we've got right now in the system. And then one thing that we're going to add is what are we actually optimizing for. So typically you optimize for units, but really what you always want to do is optimize for revenue or for margin. Because of course it may turn out that a lot of people buy a lot of books from the list of books that has the recently reduced offers, but you're not making much money out of each one of these recently reduced books, whereas maybe not as many people buy books from the recently released books, but those are typically more expensive because they've just come. So these are some considerations that you need to make, and this is a strategy that is so as I said, it's good for multivariate testing, it's good for continuous optimization, and it's theoretically more sound than running A/B tests, or not more sound, but just more profitable. And finally, I want to touch on user reading behavior. So that's another one of the interesting aspects. We can track how people are reading. So if any of you have seen Daphne Koller's TED Talk about Coursera and MOOCs, so massive online open courses, she talks about how, it's an amazing project in the sense that it brought learning and education to people all over the world, but one other aspect of this project is that they suddenly understand how people learn, what kind of mistakes people make, where do they get stuck, what do they not understand. And I think that we are also in a similar position in the sense that we have insight into how people read on a massive scale, which is very interesting and very unique type of data. And even more than that, to some extent we're influencing how people read, because as I said, all of a sudden you can read when you're in the bathtub or on the beach. You can go on a hiking trip and take 20 books with you, or 20,000. You can read pretty much anywhere and everywhere. You can always access, not just when you're home, you can access your old books anywhere. So part of the reading patterns that people used to have are also changing because of this new technology. And so that's very interesting. And we've only really started looking at it. So this is one of the things we're planning to focus a lot more on. So we already know some interesting tidbits. So we can tell you that pretty much everyone reads on a Sunday more than any other day of the week, so that makes sense. We also know that pretty much everyone reads more in August as opposed to every other month of the year, except for places like Australia or New Zealand, because August is not summer vacation, it's January when they read the most. We know that there are some books that people buy a lot of, but then they never bother reading. So 12 Years a Slave is actually one such example, interestingly enough. So that's a book that only about 5% of people who download it bothered reading it all the way to the end. What can we do with this information? So, of course, it's interesting information, but how do we use it to increase engagement and so on? So some of the things we're already doing is we're tracking the consumption of the product. We see how you're progressing through a book, and when you hit a certain percentage, or say 95% of the book is already read, at that point we can already suggest to you the next best book we think would be more suitable for you. So we can do it on the app, or we can send you an email offering you the next read. But we really want to take it further and to get a more fine-grained understanding of the velocity at which you read books and the reading habits in a very detailed fashion. So right now we're actually working on collecting and setting up the analytics in a way that will allow us to get that very fine-grained insight into how people are reading. And once that's in the pipeline, we will be able to do all of this analysis, and we're also thinking about, once we have it, how can we make use of that to increase, again, engagement with people, maybe by, for example, sharing some of the insights that we have about their reading and suggesting to them books or activities and so on about reading. So that's pretty much what I had to tell you about. Thank you for listening. It's pretty hot in here, so thank you for staying. And I'll take some questions.
I'm curious, actually 2 questions, hopefully one of them's quick. I'm wondering first if you sort of are you using Solr to build your recommendation engine in that quote, or is it based on some other platform, or is it just all totally custom in-house? And then,
so it's totally custom in-house. We're not using Solr for recommendations.
Okay, cool. And then the second question is, I'm a big fan of e-ink displays, and I love reading. And I'm curious if your engine or your models take into account significantly the type of device that somebody's reading on. I imagine somebody that's using an iPhone app might have a tendency to be more distracted and read differently, or click on Wikipedia links more often than somebody like me who's using an e-ink display. And I'm wondering if that's like a, sort of just out of curiosity for myself, if you find like a significant difference in sort of reading patterns depending on the device.
We find that our best customers are the ones that have e-ink readers. So they're the ones, and we don't know why that is. Perhaps it's because they went and spent $100 or $150 buying a device, and so they want to make use of it. But perhaps it's because they don't get as distracted. As I mentioned before, we're going to start looking at the exact times and what you do when you're not reading, so that we can answer the question of, for example, are they more distracted? Which we think is the answer, but we don't know yet.
When you were explaining item deduplication, I think you briefly mentioned that you guys came up with a cool trick to, instead of comparing a book to every single book in the database, like constrain the search space. How can you describe that more in detail?
So it's a long series of various tricks. So the first one has to just do with the representation. So rather than using the full, say, TF-IDF vector, we use random projections to come up with a very compact representation so that we can hold a lot of it in memory. And there are some other associated tricks. And the other thing that we do is we know the way we set up the score, the way we compute the similarity, we know that if you don't have some of these top TF-IDF terms, you're probably not going to add up to go above the threshold of what similar is. And so we can basically hash some of the terms that are, so we create these dictionaries that tell us for each particular term what are the other books that it appears in, and then we can quickly query just the one that have the top terms, and that gives us a much more a much shorter list that we need to go through. And this is not with 100% probability, but we've kind of done the back of the envelope calculation to estimate what is the probability that we're going to miss a book, and we're fine with what we might miss. All right, so thank you again, and enjoy the rest of your day.